Hi, my name is Andreas. In this video, I will talk about the Protocol Verification Suite Asset, or just the PVS asset for short. In the smart cities scenario, there are likely to be many internet-connected devices, like smartphones or IoT devices, that may run apps that share sensitive data over the internet. These devices make use of security protocols to safely communicate over the internet. It is therefore important that these protocols actually work as intended. Otherwise, malicious third parties may gain access to sensitive data. The PVS asset focuses on modeling and formally verifying security protocols. It can be used to statically check that a protocol specification indeed achieves its security goals, such as secrecy or authentication, even before the protocols are deployed and in use. This gives us strong guarantees that the protocols that we use actually work as intended. There are three tools in the Protocol Verification Suite. These are OFMC, AIF, and PSPSP. All of these tools allow for modeling and verifying security protocols. The third among these three tools, PSPSP, is the newest in the tool suite. And among the tools in the suite, it has the unique advantage that it combines both automated verification, support for a large class of so-called stateful protocols, and most importantly, the tool is formalized in an interactive theorem prover called Isabelle Hall, or just Isabelle for short. This last point means that we do not depend on the correctness of the tool, neither the implementation nor the underlying theory that it is based on. And that gives us the strongest possible guarantees that whenever the tool says that a protocol specification is secure with respect to its goals, then this is actually correct. So in a moment, we will show how to use the PSPSP tool on a protocol that's relevant to the smart city scenario, namely the 5G AKA protocol. In this protocol, users of, for instance, smartphones that are subscribed to a cell phone carrier wants to share confidential data over the carrier's network. The user's device communicates directly and wirelessly over an initially insecure 5G network, first to a cell tower. This is a serving network in the figure, and the serving network then communicates with the carrier over a wired connection. To protect the user's data, the 5G AKA protocol aims to mutually authenticate the user with the carrier and to establish a secure channel between the user and the serving network. I'll now show how to use the PSPSP tool to verify a specification of the 5G AKA protocol. Installation instructions for this tool can be found in this link here that I've highlighted. After installing Isabelle in the tool, you can open up Isabelle JEdit with a line like this down here. And if you have installed the sources of the tool in this directory, you need to give this command like this here. After loading Isabelle, the first thing we do is to import the protocol specification. I put the specification in another file called ak5g.track, and I use the track import command to import it into Isabelle. I won't go into, this is the protocol, by the way, protocol specification. I won't go into details how this works. The protocol's behavior is defined in terms of so-called transactions. Together it defines the behavior of the participants, and some transactions that specifies goals, such as secrecy goals of session keys and authentication goals. So to prove the protocol correct, you simply have to run a couple of commands. First, here in line 7, I turn on some timing measurements so we can see how long each command takes. The first command that we need to run is a protocol model setup. that takes the name of the protocol as specified in protocol specification. Then we need to compute a fixed point. I won't go into details what this is, but this is what the tool needs for verifying the protocol. This is something the tool needs for verifying the protocol. And this command, protocol executes a proof that we call in line 11, actually performs the proof that the protocol is actually secure. Now this might take a while, and we have a command that makes it significantly faster, which is called onSafe. This makes use of Isabelle's code generation, and even though we call it onSafe, this is actually just as safe as any other tool. It just means that we now depend also on the code generation of Isabelle. And when the command successfully terminates, we can then expect the protocols, expect the theorem that says that the protocol is secure with respect to its goals and the underlying protocol model that we're using. This is a technical statement, so we won't go into details with this, but that is possible to inspect like this. So this video gave a small demonstration on how to use the protocol verification suite asset on a protocol that's relevant for the smart city scenario. Thank you for your attention.